Right. So next topic is production and detection of polarized light. There are basically three types of polarized light. One is plane polarized light. Second one is circularly polarized light. Third one is elliptically polarized light. And for distinguishing, it is unpolarized light. These are the four types of light that we need to generate and identify. Okay. So plane polarized light we have seen already that when light passes through any optical active crystal, light is polarized along the optic axis. The oscillations along the optic axis only will be passed through. Right? So, when you pass this polarized light through a rotating crystal, if you start rotating this crystal in 360 degrees, so when the angle becomes 90 degrees, output will be 0. Output intensity becomes 0. Right? When theta is 90 degrees, intensity is 0. And when theta is 0 degrees, intensity is maximum. Right? So, when this light passes through a rotating crystal, and so we call it as a Nicol prism, rotating Nicol. We will be able to detect polarized light. That's it. So this is production of plane polarized light. So when light passes through Nicol prism, plane polarized light is generated. And when it again passes through the same Nicol prism with 360 degrees rotation. So when you keep rotating that Nicol prism, there will be fluctuations in intensities. So if that intensity becomes 0 at any point, then the incoming light is plane polarized. Right? So otherwise, if it is not 0, the incoming light may be any of these. It may be unpolarized light, it may be circularly polarized or elliptically polarized light. So we can identify plane polarized light when it is passed through Nicol prism, rotating Nicol. When the given light passes through rotating Nicol, and if you observe a 0 in the intensity at any point, it is plane polarized light. Okay, for other lights, the minimum may not be 0. So next one, circularly polarized light. How to generate that circular polarized light? We use a quarter wave plate. So when light passes through, when unpolarized light passes through quarter wave plate, circularly polarized light is produced. Then how to detect that? How do you identify whether that given light is circular, polarized or not? So to identify that, we have to again use another quarter wave plate. So then it becomes plane polarized. Then use a rotating nickel. So whatever light you have given, pass through quarter wave plate, then use rotating nickel. If the output intensity has a 0, then the incoming light is circularly polarized. So pass the incoming light through quarter wave plate. If it is circularly polarized, it becomes plane polarized. Then pass it through rotating nickel, it becomes it gives a 0 minimum intensity. If it is non-zero, input may be different. Okay, so the first test is directly pass it through rotating nickel. You will be able to identify plane polarized light. If it is not plane polarized, you have three options. Then pass it through quarter wave plate, then rotating nickel. If in this case, if the minimum intensity is 0, the incoming wave is circularly polarized. So plane circular is completed. So then elliptically polarized light. Right. So here the optic axis of the quarter wave plate is exactly perpendicular to the incoming light. In that case, both O ray and E ray will travel with a particular phase difference of pi by 2, and we get circularly polarized light. So because the stretch along x-axis and y-axis are equal, so in that case we get circularly polarized light. If the stretches are different, along x-axis if the stretch is lower and along y-axis if the stretch is higher, then we get elliptically polarized light. So how to generate that? To generate that, we have to generate a phase difference other than pi by 2. So if the phase difference is exactly pi by 2, on x-axis we have 0. Let's say, if the phase difference is exactly pi by 2, what is the situation? On x-axis when you have 0, on y-axis you have 1. Right? On x-axis if you have 1, on y-axis you have 0. Like that, there is an exact match between x and y coordinates. One is 0, one is 1. Like that. If the phase difference is different other than pi by 2, the phase difference is other than pi by 2, so in that case we have to keep the quarter wave plate at an angle other than normal. So then a phase difference other than pi by 2 will be introduced. Phase difference other than pi by 2 will be introduced. So at the same time, intensities also will change. Intensities also will change. So OA and E ray will have different intensities because of that orientation difference. So we get elliptically polarized light. So tilted quadrilateral. So for that we have to use plane polarized light as input. So instead of unpolarized light, we take plane polarized light. So here also, if you introduce another quarter plate here, what happens? You take plane polarized light as input and use another quarter plate. You get again circular polarized light. So at this stage, take plane polarized light and use a tilted quarter plate. You get elliptically polarized. So how to detect that? Again use another quarter plate, whatever incoming wave, use quarter plate. If it is exactly circular, you should get plane polarized light. If it is exactly circular, you should get plane polarized light. And then use a rotating nickel. Use a rotating nickel. Okay. Right. So use the same test. Pass it through quarter wave plate and then a rotating nickel. If the intensity is not zero, minimum intensity is non-zero, then you will have plane elliptically polarized light. Right? So and for unpolarized light, so pass it through nickel, then rotating nickel. So you will get zero intensity. So unpolarized light when passed through a nickel, you get plane polarized light, and when it passes through rotating nickel, you get a minimum intensity. So that is how you identify unpolarized light. So after passing through quarter wave plate, then through rotating nickel, if the minimum intensity is zero, it is circularly polarized light. After passing through quarter wave plate and rotating nickel, if the minimum intensity is not zero, it is elliptically polarized light. So we'll be able to distinguish all types of lights. Like first test is directly pass through rotating nickel. If the minimum is zero, it is plane polarized. Otherwise, you have three possibilities. Then pass through quarter wave plate and rotating nickel. Circular polarized is eliminated if the minimum is zero. If the minimum is not zero, you get elliptically polarized. In all the cases, final option is pass it through nickel directly again and then rotating nickel. You get unpolarized light. So even if you send plane polarized light, you will get zero here. So to eliminate that, we have to test that first. Directly pass through rotating nickel. If the minimum is not zero, then pass through nickel. Will identify plane polarized. So that's all. Various methods of production and detection of polarized lights. Various types of polarized lights.